So then we are back with the DKW SB 350 1934. We have been fixing the crankshaft here. This has been a difficult shaft to align and true. The reason for that was I had to push in the pin once more in order to, there's something wrong with or the steel was hanging or something, but anyhow, now this crankshaft is true. It's within 0.002 millimeters, and the spec for this shaft is 0.006, and I think the 0.002 is actually imperfections in the shaft, because when I move the clock around I get somehow a little bit different readings. This shaft is it's old and but now it's true. It's completely straight and ready to be mounted in the engine. And now we will assemble the cases and adjust the side play of the shaft. And when we start with that, there's another issue here, and the issue is has to do with the shaft actually, because here the bearing has spun. This we saw when we took the shaft out the first time when we are doing the disassemble of the engine, and we can see that the bearing here has spun. So what we have done, and of course the reason why the bearing has spun is that the shaft was really out of balance. So it has been wobbling in here, and I guess it has been so much stress on the bearing, so that eventually the bearing has started to move. And also there's a crack here, which also is you have to my conclusion is that this has to do with actually the shaft is out of true, a lot of stress, and there's been a crack here. And this crack here is in the sealing surface of the sim ring, so it doesn't really matter if we get to close it. And then we are using Loctite 638, which is to this is a product to actually glue circle surfaces like bearings. So I have heated up the case here and put the Loctite in the crack, and this is also a surface which doesn't have any stress on it. This is only the oil sealant. So my belief is that when we put on the cap here, I think this will be good. The problem is when the bearing is spinning. So what we have done here, I'm not sure what it's called, but it's called nibbling or something, but where you actually use a chisel or a door like this and make some marks in the bearing surface in order to, this is like a last chance solution to prevent the bearing from spinning. In addition to that, I will glue the bearing with Loctite 638. If this doesn't work, then you don't have any other option than you have to bore out and put in a new cylinder, and then you have to line hone and line bore and line hone and everything, and this is a huge operation. So we are trying to not go that way. There has already been done this before, made markings in the surface for the bearing. So this is the second time we're doing it. I've done it now. Use a hammer and just punch it in here, and makes the surface a little rough in order to get the bearing to set. Here the bearing is in. Now we put the bearing in here. I'm thinking that I only insert the bearing of the inner side, because then I can mount the cases dry and check the side play of the crankshaft before we do the rest of the bearings, because here you have bearing spacing spacer bearing, and here we have bearing spacer bearing, and we have to install it with the rollers and everything in order to get the correct reading of the side play of the crankshaft. And the book says you should install it dry without any gasket or sealant, and when you're finished you put on a very thin sealant, and I have a sealant which I'm planning to use here, which is not silicone. It's a very thin glue almost, used for all engines. We'll come back to that. Yeah, then we start and we see where we're at. So what we do now, we insert the lock spring here, and then this is they call it some kind of spacers that the rollers goes against, so it doesn't have this opening here. We put in both of them, and then we take the second lock ring on the other side. There. Now we can insert the rollers, but I think I'm going to do that after I put it in the case actually. Then we apply some Loctite 638, which is supposed to be one of the strongest one for this, and you can actually glue the bearings to the surface, and that's good here because we are trying to find a solution where we don't have to bore out and put in a new cylinder. The thing now is that I don't know how far this is supposed to go. The book doesn't say, it only say that you insert the bearings and then you measure. If it's incorrect, you open and you do it again. So I think we will try here. Now it's like almost the same here. Maybe this is a little bit higher. I can take it a little bit back, I guess. Like that. Now it's pretty much the same, and then we have to see if we have to take it a little bit down or if it's okay. Then this is ready to insert the rollers. Then I think I will use some grease for that. Okay, then all the bearings or rollers are in and the bearing is complete. We can grease this up more when we know that the play of the shaft is correct. We put this away, and then we have to install the rollers and this bearing as well. You don't need to take the outer bearings in either of the cases in order to check the side play or the end play of the shaft, because that's determined by the space between this bearing and this bearing, and the spacers, of course. And then we need to remember the two spacers that we are putting on the crankshaft before we're installing it. Guess what to do now? Let's remount this here. I'm checking if the shaft is going freely. Nothing that seems to stop it. Any friction at all. Seems very good. I can already feel now that this is too tight, because now the parts are not they are not perfectly fitted, and the crankshaft is actually locked. So we have to push in the bearing for sure. Give it a little bit tap just to see if it lines. Nope, doesn't. That means that this bearing has to go in a little bit further, and that was also what I expected, because this is you can see it's a little bit far out. That was the other one as well. Okay. There's no end play at all, and it's not tightened, so I guess there's no point doing that either. You can just take the bearings and push it in a little bit more. That's too much. What I'm doing now is that taking this a little bit on the feel, because the side play is supposed to be 0.1 to 0.2 millimeters, and this was a little bit too much, I think. I can't feel any side play at all, which means that we need to nope, nothing. Too much. Way too much. Now there's nothing. This runs really smooth now. So now I'm going to tighten the screws, and then we check the side play of the crankshaft. I'm not sure if you are in the spec, but let's see. So this is now a dry mount without sealant and without the outer bearings of the crankshaft, only the inner ones, just to save us some time if it doesn't work. It runs smooth and freely, and then we need to fix it on the vise and see if we can find a way to measure the side play. And I guess I will have to mount the micrometer on the engine so we don't get any disturbance from the table. We have some end play here now. we have to check how much it is. It should be 0.1 to 0.2 millimeters. And the challenge now is that the cases are aluminium and this one is magnetic. So we have to make a fixture here. You could put it on the vise, but the problem then is that you will have some, there will be some movements in here. This grip here is rubber, so that won't work. You will have a slack here, which will transform into the micrometer. We need to fix the micrometer on the case, and then we can check. So what I figure out is that I take one of these steel bars, and then I lock that in place with another vise. There, and then I can mount the micrometer up here. That should work fine. Zero this out, and then we can see it's actually 0.12. It should be between 0.1 and 0.2. So this is within spec. Now this is dry mount without the sealant. So ideally my plan was to put it on 0.1 and then we put the sealant on. But I think we do that. Actually we split it again. I will drive the bearings in a little bit and then measure once more, because I want it to be on 0.1 or a little bit below 0.1, at least 0.08 or 0.1, because the gasket will fill a little bit as well. Now before we are test mounting the case again, I'm doing the outer bearing, installing the spacer in here and the outer bearing. The reason for that is because when I'm tapping this in, I might conflict with the inner bearing and move it a little bit inside, and then of course you have to do the whole measurement with the crankshaft again. Because the bearings have spun, on here you can see that the crankshaft has actually been making a crack in the case here. This we have fixed, and now that's why we are mounting the bearings with Loctite 638, which will lock them in place completely. You have to warm it up to get it out again. Hopefully this will not get out in the next 20 years. Insert, put in some grease and put in the bearings, the rollers in the bearing, and then we can dry mount one last time, or maybe, no, I wait. Actually, I will wait. I don't put in the rollers now. Now it's in place, and I can do the measurements, and I will put in the rollers. That's the last thing I will do actually, because that will probably just drop out. Now we have opened the case. I think I've had it up about 7 times now, trying to figure out the the end play of the crankshaft. The end play should be between 0.1 and 0.2 millimeters. Yeah. Now it's mounted. Hopefully for the last time. I've zeroed out the dial. Yeah. There. And as I said, I want this to be on the lower side, so 0.1, because this is a dry mount without the sealant. With the sealant on, it will increase a little bit. But let's see. Take the crankshaft all the way back, and then I push it in, and it's, yeah, you see there, 0.8, 0.9. That's a perfect fit. With the sealant, it will be above 0.1. That's exactly where we want it. So this, I say, it's a perfectly slack in according to the spec of this crankshaft. And as you see here, we made a mount on the top of the bottom of the case, side of the case actually, with some steel, because I want the micrometer is magnetic. I want it to be stable. You cannot fix it on the grip because there will be some end play here in the grip part, especially here where I have rubber to protect the case. This now is dead steady on the case, so you will have a perfect measurement of the end play. So I'm quite happy with this. Now I will take it off, take it apart again, insert the rollers, and have the sealant on, and mount it once on last time actually. Now I have mounted it 7 times, now there's the 8th and last time. And now we're ready to mount the cases. We use this gasket cement aviation form gasket 3. This is commonly used on all old engines. This is a very thin gasket. It doesn't build up as much as silicone will do, and that doesn't work here. So this is, I think, would be a perfect gasket cement to use on this engine. The bearings are greased up, it's ready to be mounted. So now I just apply the cement on both sides, a very thin layer, and then we mount it together. Ja, hva skal du sveise av? Vis meg hva det er da.
Jeg tenkte til å både lage noe sånn siktegreier, kanskje noen blåsekanon.
Ja, da må du bare finne det du skal ha. Du må bare lete etter det du trenger.
Tenker du å bruke denne her til noe, pappa?
Nei, den kan du få. Now it's ready to be to the crankshaft to be mounted here. And what I will do now first is to apply some assembly lube. And here, just so it's not dry when it starts up the first time. There. Jeg bare prater litt. Okay, now we mount the bolts. I use a thread lock, a very soft one. Here. Should be good. Now just check if the crank moves freely. It does. Very good. And you should also check that the rod is in the center of the parting of the cases, which it is. And also that it's level up here. It is. And then we can start to wipe off some excess gasket materials. Of course, this will the gasket material here will probably melt a bit when the engine is hot, and it will start to drip out, and we have to do some more wiping before it sets. But I do clean off what I can now. And then the case already. It's mounted with bearings, new rollers, a new trued crankshaft, which is now perfectly aligned. The end play of the shaft is 0.08 before we added the sealant. Now it's above 0.1, which is between 0.1 and 0.2, which is the spec.